Okay, this is Professor Elliott. Hello again. And in this video lesson, we will look at the swamped CE or common emitter amplifier. If you have not done so already, I encourage you to pause this presentation and go to my Professor Notes handout manual and take a look at the standard CE amplifier. And I would assume by this point we've covered it in class. Look at your notes before going on to this. So sometimes the swamped amplifier is utilized to provide more stable gain. You appreciate that with variations in the beta DC, that you can have fluctuations in the Q point, and because the common emitter amplifier, the voltage gain is relatively large. Sometimes across devices, you'll have significant variations in gain, and that may or may not be acceptable. If it's not acceptable, the engineer/designer may elect to what's called swamp the amplifier. So if you were to just ignore resistor RE1 for the moment, you'll see the standard emitter resistor with the bypass capacitor C2. That's the standard common emitter amplifier. If we're going to swamp it, then we add in an extra resistor here, and notice that resistor is unswamped. Okay, so here's all the important points here is because of the swamping resistor RE1, then we're going to deal with have to live with a much lower gain. On the trade-off for that, of course, the voltage gain will be more stable across different transistors, and that may be an advantage. So both resistors RE1 and RE2 are part of the DC emitter circuit. So the capacitor, as you recall, looks like an open as far as the DC is concerned. So the DC can sort of see, in quotation marks, RE1 and RE2 in series together. But the AC, though, RE2, the low reactance of C2 effectively bypasses it, but it still sees RE1. So anyway, so make sure you go over this. Those are the few of the important critical points. Okay, so. All right, and here you'll see the circuit here. Okay, and this is the swamping emitter bypass capacitor, and this is the DC model. Essentially, the real difference is that as far as the DC goes, when we're calculating R in base, okay, we include both RE and RE1 because they're both exposed to the DC. And as far as the AC goes, when we're calculating Z in base, then we have to include RE, resistor RE, in series with R prime E, because this resistor is not bypassed by the capacitor and is totally visible to the AC. So other than that, and here are the critical notes, the circuit is pretty much exactly the same analysis and solution as the standard common emitter, just take into account these notations and these as well. So anyway, okay. So if, for example, you had a common emitter amplifier and you wanted an effective overall gain of 100, but stability was an issue. So for example, so you could have two stages, two different transistor stages, and the first one has a gain of 10, and the second one has a gain of 10, and a gain of 10 multiplied by a gain of 10, so they're cascaded together, gives you an effectively 100 overall. And you'll have the same gain as over here, but with a much higher level of stability. Right? So that's really for the engineer to decide which one is most appropriate. I'm just showing you that it's just another option. Okay, so thank you for watching, and we'll catch you soon. All right, cheers. Bye-bye.